Hi, I'm Jennifer Dunn with the National Weather Service, and this is the recording of the 2020 SKYWARN presentation. As our office continues to follow CDC guidelines regarding COVID-19, this year's recording is a little bit different than previous years. Instead, we have taken a recording of an online class that we gave back in late April and edited it some to make it available here today. So let's go ahead and review first a few disclaimers before we get into the presentation itself. First, because the following video is a recording from our online class in late April, please ignore any references to the time, the day, an upcoming break in the presentation, and references to a certificate and the code at the end of the presentation. This course is designed to serve as a refresher, therefore no certificate or passcode for a certificate is being offered with this recording. You cannot download or record this presentation either. The images and photographs used in this course are used with the permission of the original creators. Therefore, due to copyright infringement, no images from this course can be used without the express written consent of their original sources, which we have obtained from each photographer or videographer to be able to use for educational purposes, for the purposes of SKYWARN training. So let's go ahead and jump into the class now, and we'll pick it up near the beginning.
So the goals of this class tonight are to look at a lot of severe weather pictures and video and hopefully train you to identify the different parts of the storms, which will help you to become better at recognizing the various threats and what the most important parts of the storm are, which, as I'm sure you'll find out, there are almost all parts of the storm are important because they all have different threats with them. We're going to go over criteria for reporting severe weather to the National Weather Service. Now, if you are involved in some other type of group operations, such as amateur radio or public safety of police and fire, your reporting criteria might be different. So make sure that you know that reporting criteria. But what we talk about here tonight will be the criteria for the National Weather Service Fort Worth office. Also, one thing to add on there too, if you are viewing our presentation from outside of the North Central Texas area, your contact information and your reporting criteria will likely be or could be slightly different. So if you need help getting in contact with your local weather service office, we'll have an email at the end that you can email us. But you can also find our national webpage and quickly hopefully figure out where your local weather forecast office is. So how to report to is very important. We're going to talk about the 5 important questions that you need to answer when you're making a report. And then we will review safety in the second half because safety has to be your #1 priority as a storm spotter. We want to make sure that you're taking care of yourself first and then making a report whenever it is safe to do so. I just want to give you a little bit of background about our office. As I said, we cover what is called North and Central Texas, which is consisting of 46 counties that you see on this map here. Our office is located in the northern portions of Fort Worth. That's why we get our name of the Fort Worth Weather Forecast Office. But we cover everything from the Red River down to the Fort Hood and Killeen areas, a little bit of East Texas, and then we don't quite go as far west as Wichita Falls and Abilene, but we do have some of our counties out there. Since weather is a never-ending business, we always have 2 forecasters on shift at all times. So we operate 24 hours a day, 366 days a year because this was a leap year. We're here on holidays, weekends, overnight, always at least 2 people on shifts. So we work a very interesting work schedule of rotating shifts by doing that over about 8 to 9 hours. Our office staff consists of about 15 degreed meteorologists, and then we have a wonderful group of support staff, which includes everything from information technology officers, electronic technicians who keep our computer systems and our weather equipment like the radar up and running. We have people who also work on volunteer weather equipment. Our wonderful administrative assistant makes sure that we're following all the rules and staying within our budget and making sure we're filling out our time and attendance correctly. And then we also have a hydrologist on our side, which is our link between our office and the River Forecast Center that watches a lot of the rivers in the area and uses their models to predict how high or how low some of those models will be, especially after heavy rain events. So that's a little bit about our office. As you can imagine, with 46 counties, it can be very busy in our office when there is any type of severe weather going on, especially when we get those big squall lines of coming through in the evening hours, sometimes those late afternoon evening hours. They come in from the west and they can cover a very good portion of our coverage area. That's kind of what we call our 46 counties. So when there's a lot of severe weather going on, our meteorologists are in the office and we can't be out in the field watching to see actually what is happening. And that's where our spotters are so crucial to our severe weather and hazardous warning operations here in the North Central Texas area. Our storm spotters provide that ground truth between the tools that we're looking at and what is actually happening. And we have some great tools. We have satellite, we have radar, we have weather models that continue to get better and better. And then we have automated weather observations that are taking real-time surface observations also. But because these are tools, they also have certain limitations also. So we really need to know what is actually happening at that ground level. In fact, the satellite and the radar cannot show us what's happening at that ground level. They'll kind of show us the radar is up at 100 feet. So it is only sampling anything from 100 feet and up. So we really need our spotters to give us that ground truth so that we can place the link between what we think is happening using the tools we have and what is actually happening out at the surface there. The reports that you send in also serve your local officials in the area also, so they know what to prepare for and they know where they need to respond to or provide assistance. So your reports not only serve us, but they serve many other of our partners and local officials in the North and Central Texas area and around the country if you're joining us from other parts there. So who is a SKYWARN spotter in North and Central Texas? We always get a lot of questions about what do I need to do to become a SKYWARN spotter? Well, by going through this training here, you are now an official SKYWARN spotter. We appreciate you taking the time to go through this education with us. We do not issue spotter IDs or ask for contact information for our spotters. We simply have too many here in the North Central Texas area, and that's honestly not a database we want to maintain. So we kind of go on a trust and an honor system that when you identify yourself as a trained spotter, that you have been through this class with us, you have that extra background and that extra knowledge of what we're looking for and how to report and what our reporting criteria is. Many of our spotters do operate within groups. However, not everyone does. Those that operate within groups usually have formal activations of their groups at the request of the National Weather Service or other local officials. However, sometimes those formal activations are not always called out, or they're not called out in time, especially for storms that develop very quickly. So we just want to emphasize that for those of you who do operate in groups, we want you to know what the criteria is, what their procedures are. But regardless of formal activation from a weather service standpoint, we appreciate reports at any time. So if it is hailing at your house and you have not received a formal activation, please use the other methods that we're going to talk about here in a little bit to get your report to us. We really need those real-time reports as quickly as we can. Many of our spotters operate individually, which means they aren't part of a group, or maybe they're not yet part of a group, and they simply report from wherever they are at the time, whether it's their home, their place of business, maybe if they're driving, but hopefully pulled off on the side of the road. They just report their weather using any of the other methods that we have for reporting to our office of just kind of what's going on where they are. And one thing we want to emphasize is that all spotters should remain weather aware whenever hazardous weather is expected in our area. And this is regardless of whether you are an individual spotter or if you are a group spotter. And what it means to be weather aware is that you're keeping up with the weather, especially on days that we or the local meteorologist in the area are talking about the potential for severe and hazardous weather. So maybe you're keeping an eye on the forecast every 2 to 3 days out. And then when the day comes that we're talking about the possibility for severe weather, you start monitoring for when watches are issued. And then when warnings are issued, because that means that severe weather is in your area. We want action to be taken, but we also need those reports from the weather spotters at that time. So just remaining situationally aware of what is happening the days leading up to and then the day of will make you a good storm spotter that can provide good, thorough reports to our office here. So some of the goals of a SKYWARN spotter is to remain safe at all times, serve as the eyes and oftentimes ears on the ground for the National Weather Service and also your local emergency management and public safety. Communication is key with the Weather Service, and we really appreciate those real-time communication or reports when they come in. However, we want to make sure that you are staying safe first. So if you cannot make a report at that time, that's okay. Please take care of yourself and your safety first, and then you can make a report after the fact. We greatly appreciate reports after the fact too. As storm spotters, you hopefully can relay good, thorough storm reports, and we're going to look at how to do this as we go throughout this presentation today. Now, the next couple of slides, we're going to talk about reporting to the National Weather Service, and I'm going to jump out of my presentation here. The next couple of slides is information that you can also find on our SKYWARN webpage here. So underneath from our home webpage, which looks like this right now, if you look at the local programs there on the right-hand side, the fourth one down is SKYWARN. And so there are a couple of tabs with lots of information here, including certificates, which we will come to later in the presentation. But right down here is all the information I'm going to talk about in the next couple of slides. So if you don't want to get a hand cramp writing it all down, all that information is here waiting for you. So let's go back to, I'm going to switch back into PowerPoint, and I've got to do one screen switch, I know here. Our wish list consists of about 4 or more main topics. One, of course, is tornadoes, or any sign that a tornado may be developing. And we're going to talk about those signs here in the first half of the presentation. But tornadoes or signs that one may be developing is something we would like or need reported to us almost immediately if you are able to do so. Flash flooding is very important to us also because it is the #1 killer among thunderstorm-related events, more than the combination of tornadoes and severe thunderstorms alone. So we take flash flooding pretty seriously here in the North and Central Texas area. When it comes to reporting hail, we ask for reports that are penny size or larger. And penny size equates to 3/4 of an inch in diameter. Now we issue severe thunderstorm warnings when the hail is at 1 inch or quarter size in diameter and larger. And the reason that we like to have reports of penny size hail, or starting at penny size hail, I should say, is because it kind of gives us a little bit of that lower buffer on the lower end of the scale. To kind of explain it a little bit better, if you call in a report or send us a report of penny size hail, and then we see that storm intensify on radar, it's likely also that that hail size is increasing also. So if we have not issued a warning yet, we probably need to, because we know there's already at least penny size hail happening in it. So it's a little bit of a lower end buffer for us to try and get that lead time out before the hail really starts getting larger. And the same principle there really does kind of apply to damaging winds also. Our thunderstorm criteria is not only quarter size hail and larger, but it's also 60-mile-per-hour winds, or about 60-mile-per-hour winds or larger. So if you're able to actually measure winds, whether you have a home weather station or a handheld anemometer, we really like those reports of 50 miles per hour or greater. Majority of spotters don't have that capability to actually measure winds. So instead, we really want you to just tell us what was damaged instead and give us good information of what that damage is. And then we will use the wind scales in our experience that we have to estimate a wind speed with that, or to assign a wind speed with it. It's oftentimes very difficult for our spotters to send us measured or estimated wind speeds. And I usually preach a lot when I do these SKYWARN classes that I really would like our spotters, because it's easier just to send us the information of what was damaged by the wind. And then we will be able to equate, probably a little bit easier than you, what the wind speed actually was. So when you're making a report to the National Weather Service, if you can answer these 5 questions, you will have provided the most succinct, concise, complete report that we could ask for, meaning we won't have to ask a lot of questions back of you. So when it comes to time of the event, a lot of times it's happening right then and there. But if you are making a delayed report, please make sure to try and remember, or try to tell us what time the hail fell at, or what time you saw the rotating wall cloud. And also, if it was on a different day, what date that was. So a lot of times we can use archive radar to figure that out also, but when we get into instances where there's more than one storm in an area, it can become confusing. Number 3, though, is probably one of the biggest questions that we really try to emphasize, is about your exact location and where you are. As much as we would love to know all of the roads, well, we know the interstates and highways, but all of the county roads, the FM roads, the local street names in all of our 46 counties, we just can't. But you all are the local experts. So if you can give us a reference to a nearest major crossroad, or cross streets, or reference of how far you are from a certain town or city, that will help us to locate that your location and where that report is a lot faster than us trying to Google and look it up. So we really appreciate if you can use those nearest crossroads and cross streets or reference to a city or a town. With magnitude, that's really just any other additional information that you can provide to us. And we'll see a lot of these in the examples that we go through. I put that website up there one more time because just to kind of remind you of where you can find this information that we're talking about with how to report. So amateur radio remains one of the top ways to get information to us. We have a volunteer amateur radio team that comes in on most events. Right now, of course, we are all practicing social distancing, and they are working a lot of the amateur radio lines with the radio equipment that they have at their own homes. So if you're working with them through this severe weather event or the next couple of weeks, please have patience and grace with them, as they might not be able to reach as many people as they can without the more robust equipment that we have here in our office. But when they are able to come back in, they sit directly across from our warning forecasters and have a real-time conversation back and forth of where spotters are, what reports are coming in, and we can tell them information to relay back out into the field also. And their website up there has a lot of information too about their operations and more about some information for the area. You can call our office using our handy dandy 1-800 number. The 817 number is our public phone line. It's also found at the end of our webpage. But the 1-800 number, I will warn you that if you call it, it goes to a voicemail box. So you will never actually speak to a meteorologist, and that's how it's designed. If you just leave your report as you are reporting, it projects across the office so we can hear you in real time of what you're calling in also. Email and social media are great ways to report to us also, but also good ways to send us pictures and video. With the webmaster account there, that is a great place to send any pictures or videos you might have, even after the event is over also, or in the days after that. We do try to monitor that one in real time also, so you can send us reports there in real time. One thing about social media, as it says up on the screen there, is we might not see it in real time. We realize the value and the popularity of social media, but depending on what our staffing level is at the time, we might have to put social media to the side and focus more on the warning process and the communications. Sometimes that happens when we're calling people in and we're just waiting for them to get into the office. So I would encourage you, if you have an urgent report, to call our office instead and give us that report that way, or use amateur radio. The nice thing about our Twitter and our Facebook pages is that they are public facing, meaning that you do not have to have a Facebook or a Twitter account to see what we are posting on there, but you do have to have an account or be logged in to send us a report through that or interact through there. Our Twitter, we tend to go more rapid fire and more rapid updates during an event, so it's a great way to get updated weather information as we're working through an event. I would encourage you to follow us on that if you don't already. And finally, MPing is a free mobile app that you can download also. It is a research project that is available on iOS and on Android. It's, as it says up there, it's not good only for severe weather, it's also good in winter weather also. MPing uses the GPS location on your phone to send us the location of where you are. The thing about MPing though is that it has to go up to the computer server and then come down into our office, so it's oftentimes delayed by about 5 to 10 minutes. And I do get a lot of questions of, well, can I email you or can I tweet you or call you and MPing the report? And the answer to that is absolutely yes. You're actually helping twofold there. You're helping the research project that's going on, and you're getting that report to us in a fast method. So you can do both of those. The one thing I will say about MPing though is it is a quick designed app to where you are relegated to just the drop down menus that they have. So you can't type in and add any more information. So if you have information you need to add or clarify or expand on, please use one of the other methods to send us that information. Now, we did talk about what we do want reported to us, but we actually do have a list of what we do not want reported to us. The first of that is what you see on radar and what you see on satellite. Well, we appreciate that you are using radar and satellite to remain situationally aware and see where you are in relation to the storm. The Weather Service meteorologists are looking at that same radar and satellite data feed. So we're seeing the same thing that you are. We need you to tell us what you're seeing with your eyes or hearing with your ears and give us that ground truth instead. A lot of times we get reports of, quote, just heavy rain, or that it's raining heavy, or that the rainfall rate is this. And honestly, to a meteorologist, especially in our office, that doesn't really give us much information. What we want to know instead is, what are the impacts of that heavy rain? Is it already causing street flooding? Is it curb to curb deep, or is it something worse than that? We do appreciate rainfall totals also, either during an event or after an event, as it can help us to calibrate how the radar is working, whether it's overestimating or underestimating. So if you have a rain gauge, you can definitely send us those rainfall totals during or after an event. We get sometimes a lot of reports of, quote, scary looking clouds or dark looking clouds. And sometimes those clouds are clouds that, as storm spotters, we can easily identify. So we're going to look at a couple of these as we go through, particularly the scud clouds and the shelf clouds. So we'll come back to that subject there. And then finally, the last thing we don't necessarily need reported to us is lightning, or just reports of how much lightning activity there is. We have about 4 lightning detection networks that come into our system that we have access to. So we're looking at probably a lot more lightning data than you have available to the public. But if a lightning strike causes some type of injury, starts a fire, causes damage, please, of course, call 911 or call local emergency officials and have them respond. But that type of information where it causes damage or injuries or possibly worse is something that we can document as a weather-related loss or weather-related injury or fatality. So it doesn't have to be reported right away. If it's something that you notice or can send a day or 2 later, we are required to document that when we do receive those type of reports. But by all means, please first call 911 or local emergency officials to get them responding before you call our office about that. So let's start jumping into the storms themselves and start looking at their structure and identifying some of these cloud features that we've been talking about a little bit already. So when we look at these next 2 schematics on the slide here, or 1 schematic, but it's on the next 2 slides, we're going to imagine that the storm is moving from left to right across the screen, or as they mostly do, essentially from west to east or southwest to northeast, as is common here in North Texas. So we're going to focus kind of on the back half of this storm structure that we have here, and this is what we call the updraft part of the storm. This is where all of the air is rushing into and up into the clouds. These are the billowing cauliflower, cotton ball clouds that you see building up and expanding as that updraft continues to grow or continues to rise within an already developed thunderstorm. Because all of the air is rising, though, the thunderstorm base underneath it essentially has no rain falling out of it. No rain, no hail, and really no wind in most cases coming out of it. So we call this the rain-free base or the precipitation-free base. You can essentially see right through it because there's nothing to obstruct the view of the thunderstorm base here. But identifying this part of the thunderstorm is important, because this is where wall clouds and tornadoes actually form. So this is the area that we want to identify or be watching if it's a day that we're concerned about tornado potential. We'll look at the schematic a little bit more, but one last thing that I do want to point out is that kind of this bubble of cloud or this dome of cloud across the top of the thunderstorm here, this is what we call the overshooting top. And I just want to point it out because it is a feature that you will commonly see with these thunderstorms, but it doesn't have a correlation with the severity of the thunderstorms. It might not even be a severe thunderstorm. It might just be a strong storm or not even that. But these overshooting tops you will see very commonly out there. We just can't make an inference or a correlation about the intensity of the storm based on the fact that there's an overshooting top or not. So we're going to move to the front part of the thunderstorm now. So the front half here is called the downdraft area. So all the air that has gone up into the updraft is now getting brought back down to the surface in the downdraft area. So this is where all of the air is rushing down and out of the storm. And once it hits the ground, it starts spreading out in all directions. So this is where, as I mentioned, the rain, sometimes heavy, the hail, all comes crashing down out of the thunderstorm. So it's visually evident as a very dark or murky area, as you can kind of see by this blue area on the schematic here. This is also where our damaging winds typically occur, our straight line winds, because all of that comes crashing down or is pulled down to the surface by the rain and the hail that is falling out of the thunderstorm. The shelf cloud is usually marking, or excuse me, let me start that over. The shelf cloud is usually present along the leading edge of the downdraft area, or along the leading edge of the front part of the thunderstorm. And we're going to look at these shelf clouds, some real life examples of it, but they really mark where the air is starting to spread out underneath the thunderstorm. Now, the downdraft is interesting to be able to identify also because, as I mentioned, this is the front part of the thunderstorm. So this also tells you which way the thunderstorm is actually moving. So we're looking at a real life schematic of this. This would be what it would look like if we are a storm spotter standing out on the ground looking at a thunderstorm that looks to be well developed. We have kind of our billowing cauliflower or cotton ball clouds where we can see the updraft here. We have that rain-free base underneath the updraft, or marking that updraft base. As you can see, we can see right through it, right under it. In this certain picture here, we do have an interesting, quote, lowering underneath the updraft, but this lowering is defined as a wall cloud. A lowering can mean a lot of things. So as storm spotters, we want to classify what type of lowering it is. It kind of falls under the same category as scary looking cloud. Well, what type of scary looking cloud is it? But this blocky lowered cloud underneath the updraft is what our wall cloud is. We see the dark, murky precipitation area off to the right here. This is our downdraft area where we can see rain is falling out. There might be hail. There might be damaging straight line winds. You can't really visually see all that from a distance, but this helps to tell us which way the thunderstorm is moving also. So what happens here is as the air is rising up into the updraft, you'll notice that that updraft is actually leaning from left to right across the screen here. And that's because as you go higher up in the atmosphere, or higher up into the thunderstorm, the upper level winds typically get stronger. So it's essentially pushing that storm or pushing that updraft in the direction of the upper level wind, which essentially drives that storm in the direction of the upper level winds also. So that's how we can use the tilt of the updraft and the location of the downdraft to help us figure out which way the storm is moving. Or if all we see is a wall of precipitation in front of us, it's probably a good indication that the storm is coming right at us or semi-right at us in some sense. Now, I know a lot of you do look at radar most likely. So on a radar app, we can somewhat identify some of these features also. So here we have kind of a classic supercell structure, which we're going to talk about supercells in a minute, but we have the hook echo here, and all of the colored area that you see, which is what we call reflectivity, but the green, even the blue, some of it, the yellow, orange, and red, that is all part of the downdraft. That is the rain or the hail, and remember sometimes the wind, coming down out of the storm, and the radar is sampling that. Now, if you remember, the updraft area is really all air that is rising. So on most of the radar apps, you're only seeing the very first radar scan, or what we call the base slice, the base scan of it. So your raindrops and your hail drops, or excuse me, hail stones haven't really formed at that level. So the radar doesn't really necessarily pick up or show you the updraft on the radar apps that you're used to looking at. Instead, it is inferred as being down here on the southern part, kind of meeting up here with the downdraft. So where these two come together is where some interesting things can happen, and we'll talk about that here coming up. But remember that most of the color, the reflectivity that you see is all part of the downdraft. And the updraft is usually on the south or kind of on the backside of the thunderstorm, or that's where it is inferred there. So I mentioned about how this was what we call, or most likely is, a supercell look on radar. So for lack of another way to describe it, severe thunderstorms can kind of elevate into another category. And that next category up is what we call a supercell. And you can't really go higher than a supercell. There's kind of only those two definitions there. But by definition, a supercell is simply a thunderstorm that has a rotating updraft. But it's rotation in the mid levels or the middle levels of that updraft. It doesn't necessarily guarantee you have rotation in the low levels, which then can translate down to a tornado. It's rotation, again, in the mid levels. And visually, this is probably not something you're going to see, meaning the supercell isn't going to be spinning like a top to where you can tell that it's rotating. But there are a few other visual clues that you can use that we're going to look at on the next couple slides to help you identify that it is a supercell. Now, supercells are important to identify for a number of reasons. Obviously, they can produce tornadoes, but despite the fact that supercells are rotating, not all supercells go on to produce tornadoes. In fact, the statistic there that says about 1 in 5 supercells produce tornadoes is pretty good. That means a low percentage of them actually go on to produce tornadoes. But when tornadoes do occur, majority of them do come from supercells. So it's important on days that we're talking about tornado potential as storm spotters, if we're able to identify that updraft area and watch for wall clouds, watch for funnel clouds and possible tornado development, which we're going to get to here after we talk about supercells for a little bit more. Now, we do focus a lot, there seems to be, I should say, more interest in tornadoes, but supercells also are capable of producing very large hail, very damaging straight line winds, and very heavy rainfall that can lead to flash flooding. And these are the majority or the most common threats that we get with supercells here. It's not the tornadoes, it's the large hail, the damaging straight line winds, and the heavy instantaneous rainfall. So we don't want to lose sight of that. As I kind of have talked about a little bit so far, that not all supercells produce tornadoes. So a lot of times we're instead focusing on these bottom 3 threats here on the screen when we're issuing warnings for supercells that are impacting North and Central Texas. So to kind of give you a visualization of what an air parcel or a bubble of air will take. Here we have the updraft again. We can see this case we're leaning from left to right. Our mid-level rotation is happening kind of where these yellow arrows are in the updraft. The official definition for it is the mesocyclone. So the mesocyclone is that rotating updraft in the mid-levels. As you can see by the schematic, it rotates in a counterclockwise direction, and that's very common for majority of supercells in the northern hemisphere. And it's the same for wall clouds and tornadoes. They rotate most of the time in a counterclockwise direction. So if we were an air parcel that was being kind of ingested into this storm and rising up in, it would essentially kind of just corkscrew its way up into the top parts of the updraft. It would hit the upper level winds that would push it to the front of the storm. By this time, it's probably condensed into rain, maybe even frozen and collected into hailstones, and it will fall out in the downdraft area in one of those forms. Or it might come crashing down as damaging wind. Also, there's a lot of opportunities and possibilities for this yellow bubble of rising air. Now, on this slide, I do want to introduce kind of our radar schematic again, or I want to bring it back. For the next several slides, with each of the pictures or videos that we look at, I want to show you where it is in relation to radar. So each picture will show you the vantage point of the storm spotter as it relates to radar. So very simple schematic again of a supercell with a hook echo. Our storm spotter is the the yellow star here with its viewpoint or its vantage point in the yellow triangle there. Remember, again, we're viewing the updraft portion of the storm here, and the radar does not necessarily see that, at least not on the very bottom or very base scan. So the updraft is inferred to be kind of this red sort of box, polygon, whatever I drew there on the screen of what they would be looking at, where the precipitation in the dark murky area would be off to the right from this picture here. Now, supercells aren't just automatically born. They actually have to grow and evolve over time. So our strong and severe thunderstorms will start out like any other thunderstorm that we have, where you have this billowing pile of clouds that just continues to grow and develop. And then over time, which could be anything from 30 minutes to maybe 2 hours, that they will evolve into something that looks a little bit more like what is on the bottom right here. So you can kind of see the updraft now looks more barrel or rounded shape look to it. And it also has what looks to be kind of like a stacked plate saucer look to it, where it almost looks like teacup saucers stacked on top of one another here. This is what we call striations. And striations are important to be able to identify also, because the striations are the #1 visual sign of a supercell. This is that one clue that can tell you as a storm spotter out in the field looking at a storm that you are dealing with a supercell. As meteorologists doing our radar analysis, we can detect this rotation on radar and we can send that information back out. But if you see this stacked plate or this barber pole or barrel look updraft, or some people call it the mothership, which probably looks almost pretty accurate here on the bottom right picture, this is the #1 sign of a supercell. And remember that a supercell is important to be able to recognize because it kind of increases the size or the magnitude of all the threats. So very large hail could be golf ball and larger, oftentimes baseball and larger, damaging winds over 70 miles an hour, tornadoes that can do considerable damage up on the higher end of the enhanced Fujita scale, and also very heavy rainfall that can lead to high-end flash flooding in a lot of cases. So these supercells kind of pack a 4-punch with all the threats that they have to offer. And we definitely want to make sure as spotters that we're staying safe around them. Of course, we need to be staying safe around all storms, but we want to be staying out of the path of these storms. So our first video of the night is actually a time lapse here of what a supercell looks like. I will tell you there is no audio with any of these. Some of those is for a reason. We needed to mute them for some of the creative language that is in them, but you can see the rotating updraft. Again, this is a time lapse, so you wouldn't really see that in real time. We can see the rain-free base underneath here, and what looks to be a wall cloud that we would want to keep our eye on underneath that rain-free base. The dark murky area off to the right is our downdraft area. And as this gets a little bit closer, we do start to see those striations or that stacked plate look starting to show as it comes a little bit closer here. So this supercell is kind of moving a little bit towards us, or maybe kind of like over our right shoulder in this case. So probably not a place we would want to stay in for that much longer. But for the sake of this video, it gave us a really good look at what these can look like in real time also. So I pointed out the wall cloud that was occurring underneath or starting to develop underneath that rain-free base. So the wall clouds are important because this is the area where a tornado is going to form majority of the time, because Mother Nature sometimes throws us curveballs, but majority of the time, these wall clouds is the location of where tornadoes are going to form. So remember, those wall clouds are kind of those blocky-ish lowered cloud underneath the updraft portion of the thunderstorm, underneath that rain-free base. And they take on a lot of different forms and different looks. Some of them are kind of flared out or bell-shaped. Some are more rectangular, some are more square, some extend farther down to the ground than others, but they take on a lot of different forms and looks. But what we like to see with them is for them to be organized and persistent, which means they usually maintain their position relative to the rest of the storm, and they maintain their presence, meaning they do not disappear and then reappear and then disappear again and reappear. Usually when that's happening, it's not quite organized yet. But if we're in a safe location where we can continue to watch it, if it does become more organized, we probably want to keep an eye on that. Now, you're going to see a lot of wall clouds most likely. Well, if you're not impacted by a lot of storms this spring, that's good. Maybe you won't see a lot of wall clouds, but a lot of the storms that we get here in North and Central Texas do have wall clouds. So it will be a common feature. What we're really concerned about are the wall clouds that are rotating. So not all wall clouds are going to rotate. And just because there's a wall cloud, it doesn't mean that there's a tornado threat. But when they start to rotate, or when they start to rotate faster, that usually indicates an increasing tornado potential. And you definitely want to report that as quickly as you can to our office, so that we can keep an eye on it, or check our analysis and issue a tornado warning to get some lead time if we don't already have something out there. So again, you're going to see probably wall clouds fairly often with these storms. Not all of them are rotating, but the ones that are rotating are the ones that we definitely want to be able to report as quickly as we can. And kind of as I said, starting out, most tornadoes, pretty much all of them, are going to occur underneath these wall clouds. So that's the area that we want to target when we're looking for or talking about the possibility for tornadoes to develop with these storms. Here's our radar schematic too. Spotters kind of in the same location on the other slides. But the area that we're watching is kind of down in that hook echo, not kind of, it is, down in that hook echo where the updraft and that downdraft or that hook echo tend to come together. And usually the wall cloud or the tornado formation will occur kind of near the end of the hook echo, maybe up a little more into the middle of the hook echo, again, where it meets that updraft. So the tornado formation or the wall cloud formation is not going to be back here on this backside or up here in the downdraft area. If there's a hook echo, it's usually going to be down on kind of that southern end of the hook echo, a little bit up into the middle of it. So that's the area on radar that we are typically looking for, or that rotation associated with tornadic activity typically tends to develop at. So here is a video of a wall cloud. Interesting thing about this video though is that it's very difficult to tell that the wall cloud is rotating. And you will run into that challenge as a storm spotter. Now, if you look higher up in this picture, you'll notice that we can actually kind of almost see somewhat of the mid-level rotation or the mesocyclone rotating there. But looking at the wall cloud itself, it's almost tough to see the rotation of it. And as I was starting to say before, sometimes as a storm spotter, it might be a case where you just kind of have to sit and watch it for a little bit before you're confident enough to make a report. And that's okay. So continuing to sit and watch it and looking for persistence and organization and evidence of rotation will help you to really identify when you need to make that urgent report. Now, looking at this wall cloud also, you probably picked up that looks like we have a funnel cloud starting to take form underneath that wall cloud. So definitely something we would want to keep an eye on. Those funnel clouds, again, they generally occur underneath those wall clouds, but by definition, the funnel cloud is not in contact with the ground yet. And it may never actually make contact with the ground. Just because you have a funnel cloud, again, it does not guarantee that a tornado will develop. Once it makes contact with the ground, then you will want to report that as a tornado. If it is rotating, the tornado's potential is increasing. I would argue that if funnel clouds are developing, they're always going to be rotating because that storm is trying to make contact with the ground. It's trying to go on and produce a tornado. So what you want to start looking for at this point is looking along the ground for evidence of whirling dust or debris. The interesting thing about funnel clouds is we can kind of see this ice cream cone shaped funnel cloud starting to develop underneath the larger wall cloud here, is that this actual visible funnel or visible cloud particles, I guess you could call it, may not always extend all the way to the ground for there to be contact. We need to be looking along the ground underneath that funnel cloud for evidence of whirling dust or debris or dirt or whatever it can be kicked up, indicating that contact has been made and now there is a tornado on the ground. A couple of other things that you might notice when it comes to tornadoes or the early stages or the potential increasing threat for tornadoes is that the winds flowing into the storm will actually increase in speed. Whereas they may have been 20 miles an hour before, they may increase up to 30 or 40 miles an hour as that storm is really just taking control of the environment, hogging all the humid, moist air with all that energy in it and kind of taking it in for itself while it's trying to wrap up a little bit more and potentially produce a tornado. You'll probably also notice too that the wall cloud or the funnel cloud starts rotating faster, or what we call rotate stronger in some cases. If that happens and you can report that to us as quickly as possible, please send that information to us. That, again, that's a sign that that tornado threat continues to increase and the storm may be very close to attempting to produce something. And this third one here is not something that usually gets reported to us very often. It's probably not something you're going to see if you're too close to the storm. But if you are farther out, you may notice that the updraft base becomes increasingly more circular, kind of matching that barrel look to the updraft base. But really the first two are things, the first 2 points on there are more likely things that you will notice a little bit more easily or frequently as these tornado storms start to kind of organize a little bit more and make their attempts to go on and produce a tornado. So we're going to look at a couple of videos here of the developing and into the mature stages of tornadoes. This first video here is a time lapse. However, I think we do know that cars sometimes do drive that fast anyway, but this is a time lapse. You can see our rotating wall cloud very easily here. Again, that counterclockwise rotation where it's left to right across the front right to left across the back. And then it looks like we see a funnel cloud maybe starting or trying to take shape underneath it. So we'd want to keep an eye on that if we can and look for whirling dust or debris along the ground there. Now, one last thing I'll point out before we move on from this this wall cloud into the next video is you'll notice how it looks like on the left-hand side here, all of the cloud particle or just the clouds themselves have completely cleared out. And the sun almost looks like it's shining through. That is a process of what we call, or is assisted by what we call the rear flank downdraft. That is another complex thing that we are not going to talk about tonight because I'd need about 4 more hours to discuss its role in how tornadoes form. But I do just kind of want to point out that that is something that you might notice when you're observing wall clouds with some of these structures, especially ones that are in the stages of trying to are rotating or trying to develop a tornado, is it might look like the clouds kind of clear out on the back side or on the west side of that wall cloud. Doesn't mean it's a guarantee. It's just a whole nother process going on that we're not going to have time to talk about tonight. So our next video here, this is not a time lapse. So this is slowed down. This is the same storm a little while later. Now we're keeping an eye on this wall cloud here. We can see these thin, wispy, very airy looking clouds kind of rising up into the funnel cloud or into the storm itself. This is what we call scud clouds. And scud clouds fall within that category of scary looking clouds. They also fall under the category of what we call imposter clouds, because sometimes they can take a form or a look of something else out there. But scud clouds usually don't last very long, or they rise up or move out from underneath the thunderstorm. They're great for wind tracers. So as we continue to watch our funnel cloud here in this video, I'll start that over one more time. We would want to be looking for evidence of rotation along the ground. But you'll notice that in this video, it's very difficult to see because of the trees and sometimes vegetation or terrain that's in the way. If you can safely kind of follow along or reposition yourself to get a better look, some spotters like to do that. Others don't have that capability, but that doesn't mean that there is not another spotter in a different location with a different vantage point who might be able to have a clearer view of the ground and monitor for rotation also. So that's where, especially those of you who are involved in group operations, can work together as a team, providing different vantage points where you might have to overcome vegetation, terrain, trees, buildings of that nature, because that will definitely pose a challenge to U.S. storm spotters. So this next video here is actually the very early stages of a tornado developing. As you can see, this is from the Van Zandt County tornado event back in 2017. So as I click play here, we can see the funnel cloud, but we start to see kind of debris and whirling picking up here along the ground. This is contact with the ground. This is a tornado, even though that visible funnel or cloud didn't fully extend down to the ground. It does now here at the end of that video. I'll play it one more time here, but we can see the debris or the whirling starting to kick up here. So this is contact. This should be reported as a tornado. And now it looks like it's continuing to go on and become a little bit more organized here. So we're going to fast forward with this same tornado just a little bit later. We have a tornado in its mature stages now, doing lots of damage. It's about to cross, I think it's 175 here. I would not recommend being on the road this close, and I would not recommend getting out of your car watching these tornadoes cross the road. But you can just see how it is ingesting a lot of the air near the ground out ahead of it. And it's just completely, and for lack of a better term, inhaling all that energy around it. Here, it did hit something on the other side of the road here, the highway. You can see debris being lofted out behind the storm. And we do hear about that often, where debris can be thrown or kind of lofted up to half a mile even back behind these tornadoes. So that tornado went on and continued to kind of do a damage and destructive path through parts of Van Zandt. There was one of several that we had in the county that day. Now, most tornadoes that occur here in North and Central Texas are not big, bad ones like what we saw there in Van Zandt or what we've heard about in Tuscaloosa or Nashville recently, or even Joplin, or some of the more Oklahoma ones and the Oklahoma tornadoes, which is good news for us. But it doesn't mean that they still don't do damage. So the Rockwell ISD was gracious enough to let us show this security video from the October 19th event back this last fall. These was the tornadoes that impacted the Dallas County, and then they did move up into Collin County a little bit later. We had ones in Collin County later and also in Rockwell. But as I played this video, as the storm is approaching, you will start to see debris and objects being ingested into this storm. So we can see the inflow and the way that the debris is moving into the storm. This little white ghost here in the middle there, that's the tornado. Watch it move across to the left here. It almost looks like a very skinny pencil, but you can see the debris all kind of move and follow it and shift as it moves across the parking lot here. So again, right here, kind of where the parking lot and the ground meet, watch for that little white ghost looking feature there. That is the tornado. It went on to move into a neighborhood after this where it damaged a couple of roofs and trees and other property. We don't want to obviously diminish that it was any less severe than any of the other tornadoes that we saw, because it still did destruction. It still, scared a lot of people, made them nervous. And at the same time, too, it still involves some type of cleanup for them. So it's going to be an event, no matter how big or how small the tornado was, that they do not forget and had to do some type of cleanup or insurance and damage assessment from. So we talked a lot so far about the updraft area, the backside of the thunderstorm. Of course, that's where our wall clouds and our tornadoes form. But we want to spend a little bit of time before we go to break here too, talking about what happens in the front part of the thunderstorm or in that downdraft area. Because remember, this is still where the heavy rain, the hail, and the damaging wind occur. This is where we can get our flash flooding, where we can get our large hail and our damaging straight line winds. So the downdraft area is that dark murky area that marks the front part of the thunderstorm, which is also the direction that the thunderstorm is moving. So in both of these pictures, from a distance, we were able to capture the updraft in both of these. And then off to the right, we can see the downdraft area to tell us which way that these storms are moving. So on our radar schematic here, this is ideally where we would see, or the area that we would be looking at up near the front part of the thunderstorm. Now, we've already mentioned once about the shelf cloud, and I did talk a little bit about how it marks the leading edge of the winds flowing out away from the thunderstorm, or the leading edge of that downdraft area. So the shelf cloud is usually a very long, low, wedged cloud that slopes down and away from the storm itself. Sometimes they detach from the storm and kind of move out ahead of it, but a lot of times they stay connected to it. And the thing that can help you identify the shelf cloud is one, the aerial extent of it. They will extend around, if you look on the radar image here, they will extend around a good part of the front part of the thunderstorm, even wrapping back a little bit more into the middle of the thunderstorm also, but they occur on a much larger scale than the wall clouds themselves. And immediately behind them is the dark murky area where the rain, the hail, or the damaging straight line winds may be. As the shelf cloud moves over you, there's usually very turbulent, choppy motions. That can help you distinguish between the updraft base, because the updraft base is usually very smooth and calm, whereas you have these turbulent, choppy motions underneath the shelf cloud because the air is essentially rolling out along the ground underneath that shelf cloud. For storms or supercells that are not in a line, meaning not in a squall line fashion, the threat for a tornado is practically zero up in this area. There may be a lot of scud clouds that try to take on looks of wall clouds and funnel clouds, but up in the front part of the thunderstorm is not the area we're concerned about for supercells that are not occurring in a line. We'll talk about what happens when they are in a line here in a little bit. But for isolated or storms that are by themselves, this area is not the area we're looking at for a tornado threat. So if you think you see something in there, we might want to double check and or pass it on and let the meteorologist do the radar analysis on that one. So this is a video of what it would look like if you were underneath a shelf cloud. This is as the air is rolling out, you have that turbulent, choppy motion. You can see the stronger winds kind of with the flags there blowing in the wind. And while in this video, you don't necessarily see the rain and the hail come in, it would follow soon behind this. So you could hopefully take shelter, but if you needed to make a report of hail or damage that was occurring because of thunderstorm winds, you could take shelter from that and then make that report to us either in real time or after the fact, after you can safely do so. So just a few more pictures here about this shelf cloud. Remember, again, we're looking at the very front part of the thunderstorm. I like the picture on the bottom because it shows you the aerial extent of how they can extend across the entire front part of the thunderstorm on a much larger scale than what you would anticipate a wall cloud would. And then right behind it is that dark, murky area. And then in the upper left, this one just gives you a really good idea of how these shelf clouds can slope down and away. It also gives you a different look to the shelf cloud, very similar to what we talked about with the wall clouds. The shelf clouds also can take on different looks. They can extend closer to the ground than others, or some are a little bit more smooth. Some have kind of this finger-like appearance that we see in the upper left-hand one. But again, there's not really any inferences that we can draw about the severity of the storm based on how the shelf cloud looks there. So when it comes to damaging straight line winds, this is occurring again in that downdraft area. And what essentially happens is that the middle or lower parts of that downdraft area essentially collapse. And all of the air, oftentimes rain, sometimes if there's hail with it, rush to the ground and they spread out in all directions. So it hits the ground and it's got nowhere else to go but out. And so it starts spreading out straight along the ground, almost like a wall of wind and sometimes rain moving out along the ground. And that's kind of how we get the term of straight line winds. So our schematic of a supercell, that could occur anywhere within that reflectivity area where we have that downdraft area. Any part of those within there could actually collapse. With supercells, oftentimes this is not something that you will see visually. But there are some storms that we can see these visually, and it's usually more common to see these in those summertime garden variety popcorn thunderstorms, where the storm kind of goes up and then it collapses right down on itself, and it produces what we call a downburst. And these two pictures indicate what these downbursts will look like. They kind of, when they hit the ground, they can produce these boot-like or these shoe-like appearances as they start spreading out along the ground. Sometimes they curl up on the edges, as you see a little bit on the right picture there, kind of like an elf shoe almost. But when we talk about our big severe supercells during our severe weather events, usually you're not visually going to see these downbursts. Instead, you're just going to come across, or we're going to hear about the damage that occurred because of the downburst that produced those straight line winds. When we talk about squall lines are important to be able to understand also, because the main threat with them is the damaging straight line wind. So a squall line by definition is a line of thunderstorm that may be severe, but it might not. If it's on the weakening end of it, it might not be producing severe criteria wind, which again is about 60 miles an hour. If they are strong or severe, their biggest threat is damaging wind. They can produce hail with them, but the hail size is usually smaller, maybe 1.5 inch in diameter or smaller. And then depending on how fast they're moving or how they're oriented, they can pose a flash flood threat also. So we oftentimes have to watch for a flash flood threat. Now, if we look at our radar schematic here on the right picture, the left picture here, so the damaging wind threat is greatest right along the leading edge. So oftentimes with these storms, you are hit with the damaging wind first, and then everything kind of starts to calm down. So if you remember, we talked about the supercell where you can't have the rain and the wind and the hail first, and then the tornado threat is on the back. Here you're hit with the damaging wind right off the bat, and then things kind of settle down. You might have light rain continuing, but we're really monitoring along the leading edge of these storms. Now, the tornado threat, under the right conditions, a tornado threat can exist. It's not a guarantee or a promise with all squall lines, but under the right conditions, we do have a tornado threat. The threat for the tornado, in this case on squall lines, also occurs right along the leading edge here. We're looking for kind of breaks or almost hook echoes within the line itself. These are very difficult to pick up on. We go through a lot of training to pick up on those, and as storm spotters, you probably wouldn't be able to pick up on it, but the tornado threat is also along that leading edge there. It's not on the backside of the stronger reflectivity like we see with supercells here. It's along the leading edge also. The thing about the tornado threat with squall lines is that usually the tornadoes can occur very quickly, and they can occur, because they occur quickly and they do not last a long length of time also, they can be undetected at times because they occur within scans of the radar or between radar scans. So the good thing, I guess, is that they usually don't last very long. Usually they're on the weaker end, about EF0 to EF1, but it is something that under the right conditions we do also have to monitor for. We get a lot of questions too after we get reports of storm damage is, well, how do you know if this was caused by straight line winds or by a tornado? A lot of times it's a lot cooler to tell a story that you survived a tornado than that you survived straight line winds, but it really doesn't make a difference. Both of these types of winds, whether it's a tornado or straight line wind, can cause equal amounts of damage. And we use a combination of ground surveys and also radar analysis to make a determination of if this damage was caused by straight line winds or if it was caused by a tornado. Some people have differences of opinion of what damage looks like with a tornado versus what it looks like with the straight line winds, but oftentimes they can look very similar. They can both spread the damage in the same direction. They can actually both cause twisting of the damage or debris that is being lofted in the air also, because as straight line winds kind of move along the ground, as they hit buildings or trees, they can create eddies that kind of wrap around that building or wrap around that facility, and that causes change in wind directions also. So oftentimes just by saying, well, the damage was twisted here but not here, doesn't necessarily guarantee that it was a tornado versus a straight line winds. Just like tornadoes, straight line wind damage can occur in narrow and confined areas. They're called microbursts or kind of smaller scale downbursts. The straight line winds can also have the same wind speeds as a tornado. Your tornado wind scale starts down in like the 60 to 70 mile an hour range, usually more in the 70 to 80 mile an hour range, but we get straight line winds that are that same speed also. So the real thing that we're just trying to emphasize or educate on is that while we do have certain factors that we go out and look for to help determine if it was straight line winds or tornado, oftentimes those lines can be blurred. But the main thing is that they can cause the same amount of damage. They can have the same amount of wind speeds. The damage can often look very similar also. And I'll be honest, sometimes we have to work together as a team to make a final determination to figure out what the best cause of that wind damage was. So we finished up talking about damaging straight line winds before we went to the break. So we're going to talk about reporting those also. The thing that we cannot emphasize the most is that visually estimating wind speeds can be very difficult, even for meteorologists. And usually visually estimating wind speeds results in an overestimation of the winds. So as I alluded to in the beginning of the presentation when we started back closer to 6:30, most of the time for storm spotters, sending a picture or an actual description of the damage is easier and is more useful to us being able to then equate that to what a wind speed actually was. So we're going to use a kind of a color-coded bar here to look at some examples of the various wind speeds that can occur with these thunderstorms. And again, all of the sound has been muted on these, but we're going to start at 30 miles an hour. So this is a very typical, very common type of wind speed that we see with a lot of thunderstorms here, whether they're severe or not. So with 30 mile an hour winds, you can still see the sheets of rain quickly moving across the field of view, but you'll notice that you can still see across the street and beyond. The fence is remaining intact. There's no damage to it. And our small tree here, while it is blowing in the wind, it's not bending or about to snap. And you didn't really see any of the small twigs or maybe small leaves that might have been on it being pulled off the tree also. So that's common with 30 mile an hour winds. But as we step up to about 55 mile an hour winds, kind of starting to approach our 60 mile an hour criteria, we start to see whole trees in motion, much larger trees. And you can see leaves and twigs and small branches being pulled off the tree and off to the left there. Our field of view is a little bit more reduced in that it is harder to see somewhat across the street there. So that can be very typical of what we see with winds that are somewhere around that 55 mile an hour range. But as we climb up even more on the scale, closer to about 60 to maybe 65 mile an hours, we'll see on this home video here, whoops, there we go, that we can kind of see that whoosh as the wind starts to move in, we see that second downburst there. And then you'll notice here a very large tree branch come crashing down, 2 of them actually. So we start to do more noticeable and more substantial damage as we climb higher up on the scale here. Now, close to this, just about a little bit, 5 to 10 miles an hour more than that. Here we have an example of 70-mile-an-hour winds. And this video is a little bit different in that we are higher up, so we're not actually seeing the damage that is occurring, but we still see the sheets of rain and the trees that are in full motion. And if you watch for the light pole here, you can see there, kind of in the bottom center, you can see it swaying as it fights the wind also. So sometimes by visually observing these winds, you're not going to get a very good reading or estimate also. But after the storm had safely passed, even though this was 70-mile-an-hour winds, you could go out and then do your assessment, look at what the damage is, and send that information on those reports to us also. Now that will look a little bit different than our next video because now we're back down at ground speed here, but this is almost 90-mile-an-hour winds. And you can see the stark contrast. We have large trees bending down to the ground within these winds, and that poor flagpole that's holding on for dear life. And you might have, out of the corner of your eye, caught that tree branch that went zooming by. One of the large trees in the back actually topples, but you can't even see it with the loss of visibility there. And lost my train of thought there. Oh yeah, it almost looks like you're in a hurricane there. So this is quite different than 110 miles an hour, which was taken in a hurricane here. Again, debris quickly moving across the field of view. You can barely see across the street. I would not recommend being in a vehicle in a hurricane, or hopefully if you knew a storm with these type of winds was coming at you. But my question for you is, visually looking at it, could you tell the difference between 90 miles an hour and 110 miles an hour? Or could you tell the difference between that 55 and that 60 to 65? And the answer is most likely no, that even of a 10 to 20 mile an hour difference, visually estimating them is very difficult. So that's why I really encourage spotters to instead tell us what was damaged instead, and we'll assign a wind speed to it based on our knowledge and the wind charts that we have available to us. So the damage, stepping up our scale again, with 30-mile-an-hour winds, yes, your playscapes, your background playground equipment can easily be tossed, especially if it's not secured down. Fences can be broken. Trampolines can even be tossed. They can end up, on top of homes, especially if they are not secured down. That can be very common with 30 to 40-mile-an-hour winds. As we get higher up on the scale, we can start to break off larger or kind of medium-sized, but also healthy tree branches. I do want to point out in this video, though, that as you look down the street, there doesn't appear to be very much more in the way of tree damage or tree branches that are broken. So kind of an isolated incident here that didn't quite reach the 50-mile-an-hour threshold. Maybe this tree branch was weak or had some other stress on it that caused it to break in winds of less than 50 miles an hour. And then as we cross that 60-mile-an-hour threshold, the reason that we issue severe thunderstorm warnings for 60 miles an hour is because that is when more substantial building and vegetation damage starts to occur. So you can peel off awnings off of, or even sometimes facades on buildings and businesses. You can start to snap trees and break off large tree branches. And we're going to come back and visit these pictures here in a little bit, but this is a little bit more indicative of the type of damage we start to see when we cross that 60-mile-an-hour threshold. Moving higher up the scale to 85 to 90-mile-an-hour winds, we can see that the corner of this well-built brick home has had the roof peeled off of it. It is not the entire roof that was taken off. It's thankfully a relatively small portion, but it did take the decking and the shingles. Probably had rain in there, get in the house as well. So still a considerable cleanup and probably fix or insurance job that has to be done on that. And then higher up at 110 miles an hour, you're doing much more considerable damage to these homes, where in this case, you have torn off the entire roof of this addition here, broken the glass windows. I don't know if you can tell with the trees in the background, but on the right side here, this whole corner of this house roof is missing. So you can see how the damage really steps up as we move up the scale, really crossing into the higher end straight line winds, more typical of what we would consider on the middle ranges of the tornado scale there. So this is common of what we would see with these types of damage. So as a storm spotter, we've talked about how making a good report is crucial to answering all 5 questions so that the meteorologists don't have to ask a lot of questions back. So here's an example of what a great report for wind damage would look like. They identify themselves as a trained spotter. They give us an estimate of the tree limb size. They also indicate that there's no other damage in the area, and they give us their location in reference to the nearest town. They also tell us what road they are on also. They've included the time, and as a bonus, they actually were able to send us a picture, which allowed us to kind of look at the tree damage and assess the report also. Another example has a little bit more information in it, but they did tell us that it was last night. Later on, they did tell us the time. They remembered what time it was at about 9:15. They gave us the location in Keller here in Tarrant County. Part of the roof was torn off, several large trees down with an estimate of the tree size. The fact that one of them fell on a car is a type of weather-related damage, so we would document that. And then they sent us pictures to go along with their report. And then lastly, somebody here has estimated 80 miles an hour in Denton, but they gave us the reason for why. Then they gave us the list or the description of what damage they were seeing. So all of these, for the most part, have strived to answer the 5 questions, or 4 in this case, that we talked about earlier on. Now, some examples of some not so good wind damage reports. Something as simple as trees are damaged, branches are broken down, or just simply generically there's wind damage. That really doesn't give us a lot of information. Tree damage can range from anything of leaves and twigs down to trees being uprooted and snapped or completely debarked. So be a little bit more specific on what you are reporting there, and tell us where you're located also. Saying our neighborhood or our area doesn't really give us a good idea, obviously, of where the report is coming from. If we don't have time, we might just toss that report aside, or we'll follow up with you and have to ask where you're located. One of our favorites, it's really windy here. I didn't see it, but it had to have been a tornado. Again, we'll do our assessment to try and make that final determination of why it was straight line winds or why it was a tornado, but tell us why you think it was a tornado. What are you observing, or what are you seeing in the damage there? And we'll work with you to make that determination. And if you had 70-mile-an-hour winds, but you didn't have anything damaged, unless that occurred over a wide open field, it's most likely that that 70-mile-an-hour wind is overestimated. So let's reassess what our visual estimation of those wind speeds are, and instead maybe focus on what was damaged. When it comes to reporting hail, hail can be done in a couple of different ways. Reporting hail can be done in a couple of different ways. If you look at the pictures on the left here, you'll probably notice that all of them have either a ruler measurement laid next to them or a more common household item. And if you aren't able to provide an actual measurement of the hail, providing a scale relative to a more common household item is good also, so we can hopefully accurately estimate what those hailstones are. So when you're making a report to the Weather Service, if you look at this chart on the right here, you can report to us either the actual measurements, which we have some references on the right side of the chart here, or you can give us the reference to a more common household item. We will gladly take either of those. Now, there are a couple of things that we're trying to get away from when it comes to reporting hail, and one of those is reporting marble size hail. We have a strict no marble policy when it comes to reporting hail, because marbles come in a bunch of different sizes. And if I go back here and you look at the scale, marble size hail for the longest time was referenced to half-inch hail. But as you can see, we've stepped away from that. We now have a plain M&M is measured at half-inch. So grab a pack of M&Ms and have a snack while you're reporting, and use that to help you measure the hail that is falling out there. So try to stay away from reporting what marble size hail is. The other thing that we are trying to really step away from is sending us pictures of only your hand, or only hail in your hand and nothing else to go with it. So if you're going to send us a picture of hail in your hand, please give us a measurement or lay a common object, a coin or a household item next to it, because hands do come in different sizes. So trying to get an exact measurement or a close estimate, especially for the larger size hailstones, is difficult from those single pictures. And this is what we commonly see on social media. And we ask a lot of times back, if we have time, hey, did you actually measure that? Can you tell us what the measurement was? Or can you give us a reference to some other object so we can figure out what that hail size is? So keep those couple things in mind when you are reporting hail. Now, the funny thing about hail is that it always doesn't fall in one size. It oftentimes falls in a lot of different sizes. So a quick quiz question that we have here, you don't have to type in your answers. You can just simply, think about it or figure it out there in the comfort of your home or wherever you are. But when hail does fall in different sizes, what do you report? Do you report the smallest hail size, the average, or the largest hail size? And the answer is C. We need that report of what the largest size hailstone that fell or that you were able to observe was. So it's okay to report that I had pea-sized hail to quarter-sized hail falling, but we'll put that in the comment, but we're going to write down the largest size. So we're going to write down that it was 1 inch or quarter-sized hail falling. And you may have also noticed in this picture that not all hailstones fall in nice round or spherical shapes. A lot of times, they're spiky or oblong or just kind of funny shaped. So how do you measure an oblong hailstone? Do you measure it across the shortest length, the average length, or the longest length? And the answer is, once again, C. You want to measure across the longest length. And sometimes that isn't necessarily the diameter of the hailstone. A lot of times it is, but if you're trying to measure between 2 spikes on a hailstone, measure between those to find out what the longest length is. So when it is safe to go pick up a couple of hailstones, look to pick up the largest ones that you can find, or grab a couple, take the measurement across the longest length, and then send us your report, but make sure to include when the hail was falling so we can correctly document the time of the hail. So when it comes to reporting hail, some great examples. 1.5 inch hail near these 2 streets there in Temple. Temple's a pretty big area, like Dallas and Fort Worth are, even some of our larger cities in the area. So they told us that it's on the southeast side of the town, so we don't necessarily have to go hunting for where in the town or city there it actually is. And this hail fell for 10 minutes, so that's a good information for us to write down also. Sometimes hail reporting can be very quick. I'm a trained spotter reporting quarter-size hail falling currently, so happening now. 2 miles west of Paris on Highway 82 gives us all the information that we need there. And then when hail actually does cause damage, that's good information for us to know also. So this was golf ball size hail at the intersection, or near, I should say, Texoma Parkway and Grand Avenue in Sherman. They gave us the time, but they told us that this hail was wind driven and that it broke some car windows. But they added that there was no other damage. So the wind probably wasn't 50 or anything more than that. But the fact that you had large chunks of ice being blown by even 30 to 40 mile an hour wind, it did cause some type of damage, and we will make sure to document and write all of that down. So once again, answering our 5 questions to provide the most concise and succinct report that gives us everything that we need to know about that hailstone or that damaging wind and what's happening out there. Our not so good hail reports, I'm gonna let you read them for a second while I take a drink. Hopefully that with a couple of these generic reports, you can follow up with us after to give us more information about where now is and how the size of the hailstone. Remember 10 minutes ago in Fort Worth is a very large city that covers or hits 4 different counties. So strive for a better location than that when you're in some of these bigger cities in North and Central Texas. And then some people have certain rules that the hail does not bounce when it hits the ground unless it's such and such size. But we want to kind of debunk that, because there really isn't a good research or a good analogy, or what am I trying to say? There's not a really good rule about that. If you have a spiky hailstone, it might just hit, the spike may come down first and may cause it to bounce. It might bounce just because the densities of them are different. So we want to get away from that and wait until the hail has stopped falling, when it is safe to go out, and then we can gather our hailstones and make our report. Very much like estimating winds, visually estimating hail size as it's falling can be very difficult, even for meteorologists. So wait until the storm has safely passed, then go out and look for the largest hailstones and measure the longest length and create your report from that. Moving on to flooding now. Sometimes flooding can be overlooked when there's other, quote, fun weather, including tornadoes going on. But flooding is very crucial to our mission, and getting those flood reports in is very important to us because, as I mentioned early in the presentation, flooding claims more lives each year than the combination of severe storms and tornadoes combined. But unfortunately, one of the most common flood reports that we get is high water on such and such street, which is pretty plain, pretty boring. We need some more information than that. We need to answer those 5 questions. So we're going to look at some reports here in a little bit, but in addition to the 5 questions that we've talked about with our other types of reporting, you can usually add information on flood magnitude, flood frequency, and flood behavior. So with flood magnitude, it's as simple as answering the question of how high is high. And we don't always have a flood gauge to tell us how deep the water is. And I'm definitely not encouraging you to go out into the water to find out how deep the water is, but use common things around you, like the height of vegetation or curbs or how deep the water is on cars to help you gauge or estimate how deep that water actually is. With flood frequency, answering the question of how often does this happen? Again, we would love to be experts in all of the terrain, in and outs, hills and valleys of all 46 counties, but we simply can't do that. But you are the local experts, and you know the trouble spots that whenever it rains heavy, this location fills up with water, or whenever it rains heavy enough, this spot floods. So use that knowledge that you have and that expertise to gauge how often or kind of how extreme, how common this type of flooding is as it's happening. And then floodwater behavior, we'll talk about the kind of the importance of the difference between rushing water and standing or slowly moving water here as we talk about flash flooding. So flash flooding, again, is defined as a rapid rise of water into an area that typically doesn't fill with water. So when it comes to the magnitude of it, this is where you are starting to impact and flood your main roads, not just your trouble spots or your low-lying spots, but your main roads become tough to travel across, likely impassable. Vehicles are partially or completely submerged, and you might be inundating commercial and residential structures. True flash flooding shouldn't be very frequent, but there are exceptions to that. A lot of times when we are assessing our flash flood potential here in North and Central Texas, we have to also consider antecedent conditions, including soil conditions. So if you remember back to spring of 2015, fall of 2018, and even just the last few weeks, we were in very wet patterns where it rained every couple of days. And that water just kind of collected. The soils became saturated and they couldn't hold any more water. So every time it rained again, the flash flood threat was a little bit higher because that water had nowhere to go. It couldn't drain off. So those antecedent conditions can play a big role in how we assess the flash flooding threat with each event that comes through. And then with the floodwater behavior, the reason that flash flooding can oftentimes cause so many problems is that it is likely swift moving water. And a lot of people underestimate the power of water, especially moving water. And that's where they get caught in trouble or get swept under or swept off a road. So it's usually moving swiftly, at least initially, and then over time as it's waiting to drain off or trying to drain off after the rain has ended, oftentimes will calm down, but it's still an area that we want to avoid until the water has had a chance to fully drain. So when it comes to reporting flooding, I picked 2 locations here in our coverage area. I cannot guarantee that these are actual areas that typically flood. I just randomly picked 2 areas, so don't take my word on that. But our first report is in the city of Denton, where McKinney Street and Bell Avenue come together. They tell us that there's 2 to 3 feet of water rushing across the road. And the time that it started happening at was 8:20, but it was still rising at the time the report came in. And then probably one of the most critical pieces of information is the next line, that I've lived here 20 years and I've never seen anything like it. That tells a meteorologist, especially someone who's not originally from North and Central Texas, who might be have come to us and joined our team from anywhere else in the country, that the local experts are telling them that this is becoming an extreme event because this is an area that they usually don't see this amount of flooding, but something is going on in that area that we either need to make sure we address or we need to continue to follow up on if we already have that flash flood warning out. And then our second report down in the Cameron area, several cars are stuck in high water. Fire personnel are attempting water rescues. The area doesn't flood often, but it has flooded a few times, so it's somewhat known to be a trouble spot when it rains pretty heavy, but it's known that when it rains heavy, it kind of becomes a flash flood incident in that area. And we'll ask, of course, of what else is happening in Cameron and also in Denton also. So answering our 5 questions that we had before, but also answering flood magnitude, flood behavior, and flood frequency, if you can, will really help us along. So not so good reports of flash flooding, although it might be hard to tell if they're actually true flash flooding or not. But simply generic as water is covering the road and streets are inundated or it's starting to flood doesn't really tell us a whole lot. If you can add more information to that, it'll be better for us to assess what type of product we need if we need one, meaning do we need an advisory or do we need a warning? We need an arc out here you think would speak volumes to us. It probably does, but hopefully we can add a little bit more information. I'd really like to know where you're located in case we have to come out and join you in the arc also. So really strive to answer those questions and give us a more complete report than just telling us that it's flooding or it's raining heavy or water is starting to collect. We want to know a little bit more information. Now, not to detract from the severity of common or minor flooding, I don't want you to get lost in the fact that thinking, oh, this is just common or this is just minor flooding. But as you'll see, common and minor flooding can still be fairly problematic. These are your more typical areas that fill with water though. So you can even have cars become fully or partially submerged. Here we are on a feeder road or a frontage road, whatever you call it, depending on what part of the country you may be from. But water in this heavy rain event has essentially just cascaded down off the interstate here and collected in this lower lying area. We typically see frontage roads and feeder roads fill up with water in some areas whenever it rains heavy enough. You'll see it doesn't extend up into the parking lots here where the businesses are, but they can become problematic. Roads can become impassable. But this also has a wide range from anywhere from ankle deep water or curb to curb water to something like what we see in this video also. With the frequency, obviously low-lying and construction areas can flood fairly commonly, and especially with only marginal rainfall rates, meaning it doesn't even have to be heavy rainfall. So this type of flooding usually occurs fairly frequently. As you can see in the picture on the bottom right here, this was probably a creek that was running along the road here that overflowed into affect only a relatively small portion of the road, but it's still not something we would want to drive across. It's a known trouble spot because most likely because they have put a flood gauge there, but over time it will recede back into the banks as long as that creek or that stream can get its chance to drain off of there. With common and minor flooding, the floodwater may be standing or might be moving slowly unless it is an 18-wheeler or a tanker plowing through there creating waves, as we saw in that frontage or that feeder road video there. With reporting, we're going to have the same 2 locations as we did before. We're back up in Denton. The water's not quite up to the curbs and cars can still pass. This area typically fills with water when it rains heavy. So this is kind of a known trouble spot. The water's not too deep at this point, but if it continues to rain heavy, we're going to have to keep an eye on that and look up those rainfall estimates and check back to see if we're escalating up into a flash flood event. With Cameron, most of the low water crossings are filling up with water and continuing to rise. Again, that's good information to know because if it continues to rain heavy or rain enough, it might escalate up into a true flash flood event. So just remembering our 5 questions, we're going to take just kind of a look at the different categories that we have for flooding using the same color scale that we had before. So ponding happens pretty much every time it rains. These are the areas where there's just kind of low dips in the road. It happens along curbs, along storm drains that cannot filter the water fast enough, the corners of intersections. You're used to seeing this, and hopefully you're not driving too fast through them also. With common and minor flooding, again, it happens frequently, maybe 5 to 10 times per year in your location, kind of where you live or where you work. So whenever it rains heavy enough, those are your spots that fill up with water. But Again, they can be dangerous when a bad decision is made. So we want to watch our speed and avoid trying to cross these low-lying areas until the water has had a chance to drain off. With flash flooding, while it can be infrequent across our 46 counties, it does occur a couple of times in an average year. And you need to take action to protect yourself. You might already be in higher elevation area, but there are some people that may not be, that need to get up into higher ground or get out of areas that are filling up with water, so that we don't need emergency personnel to go in and rescue you. So when we start to experience kind of on the higher end of common and minor flooding, we will typically issue what's called a flood advisory. This is where the common and minor flooding maybe is a little bit more widespread. It's causing nuisance, it's causing traffic problems. We want to address that and still try and keep people out of the area. And then when we get into a true flash flood situation, we issue the flash flood warning. And the flash flood warning will tone alert on your cell phone or your mobile device. The flash flood warning is part of FEMA's wireless emergency alert system. So if you are within the flash flood warning box, or polygon we call it, it will ping the cell phone towers in there to set off the wireless emergency alert on your phone, as long as you still have the weather alerts turned on. And we highly recommend that you still do. Wireless emergency alerts for severe weather will only go off for flash flood warnings and tornado warnings. It will not go off for severe thunderstorm warnings, because we issue a lot of those. So we want people to really make sure that they're getting the message on these higher end flash flood and tornado events. But our severe thunderstorm warnings are still crucial and important. And as far as getting those sent directly to your phone or your mobile device, there are a number of apps out there that can do that for you. So I would just do a little bit of research on that and pick the one that you like the best there. So that really wraps up a lot of our storm structure, our storm reporting portion of this presentation. We're going to talk about safety, and then we will have a 10-question quiz before we wrap things up. So when it comes to severe storm safety, we really don't want you to minimize the threat. We're issuing the warnings because we believe there, or know there to be, a credible threat of either 60+-mile-an-hour winds, quarter-size hail and larger, flash flooding or heavy rainfall that could lead to flash flooding, and or a possible or a confirmed tornado. And I know it can be exasperating when there's warning after warning when we have storms moving over the same area, and it's easy to turn those alarms off. But please, we're issuing those warnings for a reason. We just want you to be safe and to take action. So moving inside a strong building, staying away from windows will offer you your best protection from all of these storms. Mobile homes and temporary buildings can offer some protection from wind, but it's usually pretty poor. If you are caught in your vehicle in a hailstorm, you will usually be fairly safe as long as the hail is smaller than golf ball size. But once you start to move past or larger than that golf ball size, you run the risk of breaking windows. So if you have the ability to, obviously, one, not drive into the storm, but two, get out of your vehicle at a safe time and take shelter in a strong building, that will offer you better protection from those larger size hailstones. Storm spotting at night is never easy. It's always dangerous. We really don't recommend that beginner spotters go out and spot at night or be mobile spotting at night, especially by themselves. We do tend to get a lot of storms after dark, especially ones, those big squall lines that will form out in the Texas Panhandle. They form out there in the afternoon. They take several hours to move east, and they're reaching our north central Texas area by the evening hours. Lightning is one of your worst enemies, but it is also one of your biggest helpers when it comes to storm spotting at night, because lightning flashes will backlight or silhouette cloud features. The picture that you see up on the screen right now is actually one of the Dallas tornadoes as it was crossing up into Richardson on October 20th or October 19th. But as I step forward here, I will show you the next picture where he was able to capture that monstrosity there within the power flashes, the lightning flashes that were occurring. So it can help to illuminate these cloud features. The thing about it, though, is that you're likely not going to be able to identify it in one lightning flash. You're going to have to be patient and sit and watch from a safe location, a safe distance, to take a while and try and figure out what you're looking at. Power flashes which are typically blue-green in color, can be caused by any type of strong or damaging wind. It doesn't have to be a tornado. It can be damaging straight line winds also. So I specifically mentioned that they're blue-green, hopefully not to be confused with lightning. Lightning flashes typically appear obviously as white, but they also can be pink and orange, especially when they're very close to you. And I do speak of that from experience. Remember your storm model too, not only at night, but also when you're spotting also, but especially at night when it's harder to see. Remember the storm, the front part of the storm, what comes to you probably first is the rain and the hail and the wind. And then as you get closer into the middle of the storm, the hail will likely get larger. And then if everything goes quiet, it's not safe to come out of your storm shelter or to come out then. You're likely in the updraft area still. So, and there could be something bad in the form of a tornado lurking in that updraft area. So stay in your shelter for at least 10 to 20 minutes to make sure that you are cleared of it, unless you've got a radar app that is you can still have access to make sure that you are safe and clear of the storm and there's not another one coming at you after that storm. With flash flooding or just any, the common and minor flooding also, we have our handy turn around, don't drown slogan. 2 to 3 feet of water, especially moving water, will move most vehicles, meaning you will lose contact with the surface. This includes trucks, and this includes your trucks with big tires. It only takes 12 inches of water to knock a person off balance, but it's less than that for children, which is why we especially want to be careful about staying away from creeks or ditches, especially where it's easy to underestimate the power of that moving water. A lot of times, some of our parks or playgrounds can be in lower lying areas by creeks or ditches, and we just want to make sure that we're keeping our kids out away from that area until the water has fully drained off of there. And be especially cautious at night because one, it's very difficult to see the depth of the road, but it's also difficult to see if the road is even still there or if it has been washed out, depending on the magnitude and the power of the water that is happening. And by all means, please do not be like this gentleman here. Do not drive around barricades or emergency vehicles that have intentionally been placed there to try and keep you out of a flooded area. Follow what the cars have been doing in the background and make sure that you follow the detour. As you can see, these gentlemen here, these police officers are not going to go in after you to try and help you, not unless they necessarily have to. And if you have made this decision and you get stuck, now you have to put police or fire personnel life in danger too for them to come out and rescue you if that's what is in their protocol. So avoid driving around barricades and or emergency vehicles. I am hearing from a lot of counties now, not just here in Texas, but other parts of the country that are issuing tickets and hefty fines for those drivers that choose to drive around barricades and emergency vehicles. So don't want to take that risk. Just turn around, follow the detour, and find a different path if possible to your destination. When it comes to hail, avoid core punching, which means avoid driving into the storm intentionally to find out what the hail is. Just stay inside your vehicle or your building, and please don't measure hail while it is still falling. I guarantee you that that hailstone, or those hailstones, I should say, are not going to melt fast enough after the storm has passed, that you're still going to get a fairly accurate measurement of how large the hailstones were. And please do not shelter under overpasses during a hailstorm. Not just a hailstorm, but during any storm at all. As soon as one person starts to do it, others start to follow. And then before you know it, you have completely blocked the overpass or the underpass, however you want to refer to it, so that no other vehicles can get through. And now all those other people, those other vehicles are left exposed out to the storm and to the threats of the storm, and they don't have a chance to get to shelter or to get to safety. And we're starting to hear of more cases where even emergency vehicles cannot get through because they are blocked by underpasses and overpasses. So you are preventing them from getting to emergency calls and emergency needs also. So not just with hailstorms, but any storms, please do not shelter under overpasses. When it comes to lightning, we want you to move inside at the first sound of thunder, because that means that you are close enough to be struck by lightning. Stay inside a well-grounded building. And if you are in your vehicle, please try to avoid touching anything connected to the outside of your vehicle. Stay in shelter for up to 30 minutes after the last rumble of thunder. And the reason that we say that is because we hear a lot of times about bolts from the blue, but bolts from the blue are actually not from the blue. It's because there is a storm nearby. Lightning can strike up to 5 to 10 miles outside of a thunderstorm after it has passed. So that's why we say to stay in shelter for up to 30 minutes after that last rumble of thunder to make sure that that lightning threat has passed. As you can see in this video, if you had been sitting on the porch enjoying a nice cup of tea or coffee in the nice cool air after the storm had passed, you probably wouldn't be a happy camper right now. As you can see, there's no rain. There's nothing really happening because the storm has moved off in the distance. So stay inside up to 20 to 30 minutes after the storm has passed. When it comes to tornado safety, I really hope that a lot of this is review for you, but we have to make sure that we do a good job of talking about our safety tips with tornadoes each and every time. So someplace underground is best. That's usually not an option here in Texas. So a small interior room on the lowest floor without windows is going to offer you your best protection. We want to avoid open rooms such as warehouses and gymnasiums with those wide span ceilings. Hopefully they have another smaller shelter area that you can take shelter in. Closets and bathrooms are good. Take something to protect yourself from flying debris. We hear of bike helmets that are being used, you know, pillows, blankets, sometimes even mattresses have been used. One other thing you might want to consider is leaving an extra pair of shoes in your storm shelter, maybe on days where we are talking about storms, because if your house is impacted, usually when we're home, we don't have our shoes on, especially if we're lounging in the evening hours. But if you have to take shelter quickly and your house is damaged, you could have glass, nails, debris that you're trying to walk on. So having that extra pair of shoes will offer you another layer of protection also. And we know that there are locations where you cannot check off all of these points on here as far as a perfect shelter. So use the best available refuge. The smallest room, even if that's a small hallway near the middle of your residence or your place of work or wherever you are on the lowest floor, will offer you the best protection during tornado events. When it comes to vehicles, we want you to abandon your vehicle for a substantial building because vehicles essentially become like matchbox toys that can easily be tossed about by tornado winds. So do not shelter under overpasses also. We already talked about that with hailstorms, but the winds can actually become stronger underneath that overpass when there's a tornado nearby. So kind of, you remember back when we looked at the video from the Van Zant County tornado, how it was pulling up the damage or pulling up the dirt and the ground debris well out ahead of it. That wind radii extends farther out. So it's not safe to shelter under overpasses. When it comes to damaging straight line winds, we treat this very much like a severe thunderstorm. So move to the interior of your home, stay away from windows. If you are in your car, hopefully you have made the decision not to drive into the storm. But if you're in a location where you cannot get out of your vehicle into a better shelter, if you can pull off the road and if you know which direction the straight line winds are coming from and you can turn your vehicle, it may offer you some protection of your vehicle not being flipped or rolled. Our cars are designed to be aerodynamical from the front. So instead of being hit broadside, if we can turn our vehicles in, our vehicle's probably still going to slide, maybe be turned a little by the strong winds that are acting on it. But it might be better to face your vehicle into the wind if at all possible. Getting hazardous weather information is crucial to your safety, and having multiple ways to get hazardous weather information is a big success factor because not every method is perfect. So having a weather radio is a great tool to have because it is a specialized design radio that will alert you with sound if needed at any time of the night, but you can keep it on silent also. However, a lot of weather radios are plugged in are needed to be plugged in. So you want to have a battery backup, but you also want to have a source of radio and TV. And with radio, you want to know what your EAS activated stations are. There's a lot of apps and internet sites that can give you information also. And remember, outdoor warning sirens are designed to be heard outdoors, and it means go in and seek more information. So have multiple ways to get weather information, because if one of them fails, if your satellite dish goes out during the storm, or if your power is knocked out, how are you going to get weather information? If the cell phone tower is taken out, how are you going to get that weather information? So have some redundancy in how you get that information. All right, we're coming up close to the end here. We're going to do a 10-question quiz just to try and review. Each quiz really has a picture with it that I'm going to let you look at for a short amount of time, and I have a question that goes with each one of these. Now, again, you don't have to chat us the answers. You can just answer this, yourself quietly or discuss among yourself if you're watching this with a couple of other people. But after this, we'll wrap up with certificates, and I'll address just a few more things. So, question number 1, looking at this storm here across this nice, pretty field, the question is what are we looking at? Meaning, what features that we have talked about today can you identify in this picture? So hopefully in the foreground here, you were able to identify our rain-free base, possibly of a supercell. It looks like somewhat maybe of a rounded updraft or a flared base, indicating some rotation going up there. But we have our rain-free base. We don't really see any features underneath it at this time. And then off in the distance, our dark murky area is our downdraft, which means that the storm is actually moving away from us. So we are at a safe distance, meaning the storm will not track over us, but we still need to be watching out for lightning at this location. So we're looking at the rain-free base, probably of a supercell. So do you need to report a rain-free base? And the answer to that is no, you don't, unless there is an interesting feature underneath it, like a rotating wall cloud, funnel cloud, or a tornado. But just the presence of a rain-free base can just be used to help you situationally be aware of what part of the storm you're looking at and where you are located in relation to that storm. So question number 2 here, what are we looking at here? In this picture, we're actually along the leading edge of the storm here. We're looking at the shelf cloud. So again, it extends along of the entire front part of the storm here, that wedge-shaped cloud that slopes down and away from the storm. A little bit maybe of a striated look here, even along the leading edge, but right behind that shelf cloud is that dark, murky area that could be filled with hail, damaging winds, and of course, rain, as we can see in here. So do you need to report the shelf cloud? The answer to this one also is no, you don't. However, what we would want to know about is after that shelf cloud moves over you, is that rain causing flooding? What is that hail size? Is damage being caused by wind that's occurring in there? So those are the types of reports that we would want sent into our office after that shelf cloud or that leading edge has moved over you. With question number 3 here, my question is this flash flooding? And to go along with that, I have a second picture here too. Not necessarily the same location, but is this second picture an instance of flash flooding? Now, it's hard to tell from a still picture. In a lot of cases, if we had a video or a time lapse of what was happening, it would probably make us more confident to call this flash flooding or not. But we're going to say most likely in both of these cases. Here we have a street that is flooded, but the water is clearly deeper than curb to curb. It's actually spilling up closer to the homes. If it continues to rain, this could be a case where water starts spilling into these residences also. And we can get an idea of the depth by looking at the car that is stalled out in the street also. And over here on the left, while it is common that intersections can fill up with water, we can see that the water on the car in the back here is coming up over the hood, at least over the leading edge of the hood here. And if we look over to the right, it does look like the flooding extends well off to, over to the left there. So it's a little bit more widespread than just an isolated intersection here. So do you need to report this? And yes, please report any instances of flooding, whether it's common or minor flooding or flash flooding, so we have a really good sense of what impacts are happening from the rain out in these areas. Question number 4 is a picture that we have seen earlier, and we know that it did occur with some type of wind, but my first question is, what do you report if you were driving down the road and saw this? What would your report look like or sound like? What would you include in it? Hopefully you thought of the 5 questions that we have been talking about all throughout this presentation, but it might sound something like, the awning of a Napa store has been peeled off, and of course you'd want to include the location and the time if you knew what time the storm had come through. So was this caused by a tornado? Well, we don't really know. We would have to do a radar analysis, maybe a ground survey if there was other damage in the area to assess what caused this type of damage. And in this case, it was not caused by a tornado. It was actually caused by straight line winds that came up over the back of the building and just hit the awning that was standing straight up and peeled it down to the ground. But I believe it was winds of, when we looked at it, yes, about 65 to 70 miles an hour, just looking at the other damage that had occurred on the backside of this Napa building also. Question number 5, looking here. What are we looking at here? What are some of the features that we can see? Is it something we would want to report? So we do have a funnel cloud. In this case, the funnel cloud is a little bit of what we call rain wrap. Some rain has managed to wrap around. Remember, the whole storm is rotating. So sometimes it pulls a little bit of rain back around the rain-free base or back around the wall cloud also. A lot of times that rain is kind of thin curtains like this where you can still see the funnel cloud or a possible tornado in there. However, there are instances where the rain that is wrapped around is very heavy and you lose complete sight of it. And at that point, there's not much we can do. Do not go driving into that storm to try and see what's going on. Probably safer and better just to move away. If there's damage that's occurring, we will hear about it after, or maybe you can follow in after the storm to look to see if there was any damage and either call 911 or provide that information to us. So do you need to report this? Yes, we do want to make sure that we're reporting rotating wall clouds, funnel clouds, and obviously tornadoes too. Question number 6 comes back to our earlier picture also. So very similar to question number 4, what do you report? Or what does your report sound like or look like? In this case, we have a large tree trunk that is broken. We added that it was laying to the east. So if we were trying to look at the damaged path or just kind of the degree of damage that was happening, knowing which way it was laying, the damage was happening or the tree was laying is helpful. Estimated a size of about a foot in diameter, and we'd want to know the location and the time. So what caused this? Some of you may have said wind. That's a very good answer too. But again, we will do radar analysis and a ground survey to determine what type of wind that was, whether it was straight line winds or whether it was a tornado. And this again was a straight line wind event. This occurred on the same day as the damage to the Napa auto stores in neighboring cities here. So it was a pretty long swath of damaging wind, scattered damaging wind that had occurred with what probably was maybe a downburst moving through that area. Question number 7 here is, what are we looking at here? Hopefully you picked up on this one fairly easier, but this is a tornado. It does have contact with the ground. We can kind of see kind of the debris or the whirling here. The visible funnel doesn't extend all the way to the ground, but it does look like it has contact with the ground. This is the end of the Dallas-Richardson tornado. So usually by the end, it starts to shrink in size, kind of becomes more rope or snake-like, we call it. But it went from that large beast to this at the end of it. It's still in contact with the ground. It's still doing damage at this point. So do you need to report it? Hopefully you answered yes. Continue to report that it is on the ground or in contact with the ground. Number 8, what are we looking at here? What are some of these features? Aside from the airplane crossing in front of the storm here, hopefully you picked up on the rain-free base with our updraft up above it. Looks like our updraft again is probably leaning from left to right across the screen. We can kind of make out that dark murky area indicating the downdraft over on the right side of the picture here. We do see what looks to be a wall cloud. A little bit angled there, so with the trees in the way, it's hard to tell if there's something else underneath that wall cloud, if there is a funnel cloud or maybe even a possible tornado. So somebody else in a different location might have a better viewpoint. But this does bring to light one other thing that I want to kind of touch on real quick, is that if you have something that you feel like needs to be reported, especially if it meets kind of one of our immediate or urgent, or it meets our criteria of what we want reported, but you're not quite sure, you can't get a good grasp or good view of what it is, it's okay to make that report to our office, but tell us that you're not fully confident or you're not fully sure of what you're looking at. You think you have a good idea, but you're not sure, because there might be another spotter calling in the same report, and we can put your 2 reports together to get a full picture of what's happening out there. So here we have the updraft base with the possible wall cloud. Do you need to report this? First, I'll ask, do you need to report the updraft base? And the answer to that is no. But do you need to report the wall cloud? A lot of you may have said yes, but remember, we don't need all wall clouds reported to us. We really want the ones that are rotating reported to us. You're going to see a lot of wall clouds out there, or they will be common with these storms, but it's the rotating ones that we really need to know about because they may indicate the increasing tornado threat. Number 9 here, just this and one more question to go here. This is not a recent snow event or winter weather event here in North Texas. This is actually hail on the ground. So my question for you is this hail severe? Does it meet our definition of severe size hail? There's only one way to find out, and that's when it's safe to do so, is to go out and pick up a couple of hailstones and take your measurement. So do you need to report this hail? If it's at least penny size or larger, yes, definitely report that. Remember that criteria is 3/4 inch or penny size, which is what it equates to, or larger. I will add though too that making reports of large amounts or large quantities of small hail is actually an important report to us also, because oftentimes the radar will indicate that that is large hail falling. It doesn't quite distinguish that it's lots of small hail. So large quantities of small hail is good to report also. It gives us an idea of what is actually happening versus what that radar is telling us it thinks is happening as we sample these storms. So question number 10 here for the last quiz, coming back to the picture that started it all off on our first slide, what are we looking at here? What are some of these features that we can identify here? So here we're actually looking at an updraft base, a rain-free base here. We have a well-defined wall cloud. Of course, from a still picture, we can't tell if it's rotating or not. Remember, off to the left here again, it looks like the clouds have cleared out, kind of in that same video that we saw earlier. We're not talking about that tonight, but we would want to look for evidence of rotation in real time and also start to monitor for any other interesting features that might start developing underneath this wall cloud. These clouds over here on the right, these lower clouds, are somewhat of what we call a tail cloud. Sometimes they kind of extend from the wall cloud pointing towards the rain. They kind of almost look like scud also. Again, we can't really make a correlation between these tail clouds and if a tornado will or won't develop, but it's just something else that you may see out there. So we're looking at, an updraft base with a wall cloud. Do you need to report this? You don't necessarily need to report the updraft base, and you don't really need to report the wall cloud unless it's rotating and persistent. So remember those two keys.
That brings us to the end of our educational portion of the 2020 SKYWARN presentation. If you would like to review some additional resources, there are a few that can be found on our SKYWARN webpage at the URL that is at the top of this slide. On this page, you can find recorded versions of not only the 2020 SKYWARN presentation, but also the 2019 SKYWARN presentation. You can also access to print out the spotter reporting cards that you may have seen throughout this presentation. Those were the business card size cards that had our logo on it with the ruler for measuring hail. There's also a cheat sheet on here that succinctly combines to review a lot of the topics that we talked about here that you can keep with you for an easy reference when you're out spotting. And if you would like to review another type of SKYWARN, there is a nationally developed SKYWARN online. If you just search for Comet SKYWARN, you should be able to locate it. Thank you very much for viewing this presentation, for serving our region as a SKYWARN spotter, and also for serving our office and helping us during hazardous weather events here in North and Central Texas. We always have a shameless plug that if you have or if you take any photos or videos that you don't mind us using in future SKYWARN talks, please email them to us at the webmaster email that's on the screen. If you'll simply include a note giving us permission to use your media, with credit to you of course, that's all we need to go ahead and include your pictures and videos in upcoming SKYWARN presentations.